Hello everyone, I once again welcome you all to MSP lecture series on transfer metal chemistry. In my previous lecture I started discussing about the preparation of important and very useful coordination compounds and also organometallic compounds having labile ligand, so that you can do substitution reaction to make desired complexes of your choice for whatever the desired application. So, let me continue from where I had stopped. In my previous lecture I had wrote the preparation of rhodium chlorocod dimer, and that is a very useful compound. So, let me write few more complexes to make you familiar with the preparative methods. Let me give the preparation of another important compound of rhodium, that is rhodium chlorocarbonyl dimer. This is the compound I am talking about. This is a dimer having symmetric chloro bridges. This is very interesting. This is a solid state reaction. Take rhodium trichloride trihydride and pass carbon monoxide at 90 to 95 degrees centigrade. So, you get this compound. So, in this one what are the other products we are going to get? We are going to get So, later try to see whether this reaction is balanced or not. In this reaction we are getting this phosgene. Now, one has to be very careful, and this reaction has to be carried out in a well ventilated hood. So, how to do this reaction? As I mentioned, in this case we are not using any solvent. For this one it is very simple. You have to choose a apparatus like this. Have a frit here, and then you should have a side tube like this and put here CO should be a bubble. Okay, of course, the flow of carbon monoxide can be monitored by passing carbon monoxide through a paraffin bubbler, so that you know how much it is coming. You have to bubble about couple of bubbles per second, very slow, to minimize wastage of carbon monoxide. It is also very poisonous. Then what happens? It will keep on coming like this because of positive pressure, and it touches here. It will start moving carbon monoxide, and this entire place is immersed in, up to here it should be immersed in liquid paraffin and heated to 90 degree to 95 degree centigrade. It should not exceed beyond 90 degrees. In that case what happens? It may lose this water. In that case it becomes anhydrous, and that is not reactive. So, you will not get the product. And here of course this is an outlet for CO. So, in this reaction when you are doing this, the CO will react with rhodium chlorocarbonyl dimer in this formation, and of course here the phosgene will be coming out and water will be coming out, and then water vapors also will be condensing somewhere here, and then very nice crystals of this dimer will start subliming and it will come here, and you have some greyish color rhodium trichloride trihydride. You can visually monitor the disappearance of starting compound, that indicates formation of rhodium chlorocarbonyl dimer, and it is almost 100% pure. And in case if you find some dust and other things due to the impurity present in rhodium chloride trihydrate, what you can do is you take the product later, of course if a frit is there, you can add here trihexane and then you apply pressure so that you can collect it from this side solution, and then solution on cooling to 0 degree temperature, you can see very orange crystals of rhodium chlorocarbonyl dimer formation, and it is moderately stable. One can use it for further substitution reactions with various phosphines and other ligands. And in case carbon monoxide cylinders are not there, that carbon monoxide can be generated in the laboratory by using formic acid and sulfuric acid. What you can do is you can take formic acid in a flask and then add using a dropping funnel sulfuric acid dropwise, and when the carbon monoxide is liberated because of dehydration process, water and CO are formed, and this CO will try to come out to the wall something like this. So, when you add from here sulfuric acid using a dropping funnel, pressure equalizing dropping funnel, you can see the better picture in any of these books. So, here you pass here, here you have sulfuric acid, when you are adding dropwise here to the formic acid and CO will come, and this CO may carry moisture. So, it has to be passed through again sulfuric acid and bubbling through sulfuric acid and collect it here, and then this can be used here. And of course, once the reaction is complete, you can cut off the addition of sulfuric acid and you will stop it, and this reaction has to be carried out in a well ventilated fume hood because of we are handling carbon monoxide. Now, let us go to another important compound of ruthenium, ruthenium dichlorothymine dimer. I shall write the structure later, first I will give you the preparation. Take ruthenium trichloride, take ruthenium trichloride trihydrate as usual and treat with 2 equivalents of or slightly excess of cymene. Cymene is this aromatic compound having these kind of para substituents, and take this reaction mixture in ethanol and reflex it. Reflex, we use this delta, we get the desired dimer in almost quantitative yield. So, this is how the dimer looks like, and plus what we get is so this is a very useful compound in many catalytic reactions in homogeneous catalysis. And of course, this also once again when you perform some reactions with phosphines and other ligands, this breaks symmetrically here and it generates a vacant coordination site. So, there you can place a desired ligand, and of course, once you do this reaction in a polar solvent, you can also knock out one of the chlorine and again put another phosphine or use a bidentate ligand. And for removal of halogens from metal, the best method is to use salts such as silver tetrafluoroborate or silver triflate or silver acetate. Okay, silver triflate you can use, or one can also use AgPF6. So, there are plenty of such salts are available having larger anion the advantage with larger anion is if the anions are larger, the compounds readily crystallize and isolation in pure crystalline form, and also looking into the structure would be very easy. And one can also use corresponding potassium salts also if the compounds are more reactive. Otherwise, ideal way is to use some of the silver salts, and silver halide will precipitate out, and that can be separated, and you have anionic compounds, cationic complexes with these larger anions. Now let me give the preparation of another important compound, palladium allyl dimer. So for the preparation of this one has to make, to begin with, if you do not have potassium or sodium palladate, one has to make that one. That is very simple. Take palladium chloride and treat that one with sodium chloride or potassium chloride in water. You can get the corresponding palladate. Once after making this one, take this sodium tetrapalladate, treat this one with allyl chloride, So this is a method used for preparation of palladium chloroallyl dimer. It has hapticity eta 3, and another important compound is PD2DBA thrice. So of course I showed you other day preparation of palladium and platinum tetrahexystriphenyl phosphine, very useful compound. After that one, another important compound that is widely used in catalysis as a starting 0 valent palladium complex is PD2DBA thrice. So let me give you the preparation of this one. So what is DBA, dibenzylidene acetone? So this can be prepared very easily starting from benzaldehyde and acetone. One can prepare this compound in large quantities in almost quantitative yield. Few hours reaction, this is a simple condensation reaction. Once you have this one bright yellow color stuff, one can treat this one with palladium chloride using a reducing agent such as sodium acetate. This is called DBA. This should be heated to strictly 55 degrees centigrade. One should not go beyond that one. If you exceed this temperature, it may lead to some other product or some reduction of palladium to palladium 0, and that becomes useless, and also that reduces the yield of the product. Initially PDDBA twice is formed. Okay, so this is a balanced chemical equation for the preparation of PDDBA twice starting from PD palladium chloride. This PDDBA twice will be in equilibrium. So, what it does is in solution it forms this one. Plus dBA comes out. So, 1 gram of palladium chloride can give you as much as 3.5 grams of PD to dBA thrice, and of course, once after making PD to dBA thrice, if you dissolve that one in chloroform and if you crystallize, it comes as a solvated with chloroform, something like this. And if you crystallize this one in toluene, it will be solvated with toluene. Okay. Or if you crystallize in dichloromethane, 1 mole of dichloromethane will be there. And if you want to use this compound which is free from any chlorinated solvents, and if you think this chlorine will affect your reaction, better to go for toluene solvated one. Otherwise, for most of the purposes one can go for this one. It gives excellent yield, and also this compound very nicely crystallizes and handling would be very easy. How this is binding, I will show you here. It is a PD to dBA thrice, means you may be wondering what is the geometry. So, something like this. These double bonds will be binding, and of course, here you have phenyl groups are there. Okay, so another one will also bind like this. And then you have about 3.2 separation is there, palladium palladium. So, this is how it binds, and palladium has trigonal planar geometry having weak palladium palladium interaction. Let me give you the preparation of some metal carbonyl complexes. Of course, when I go to classification of ligands and discuss about carbon as a donor atom or ligands containing carbon as donor atom, I shall give you more information. Nevertheless, when we have homoleptic metal carbonyls, there are 3 ways we can activate CO bonds for further substitution reaction. One is thermal reaction. So, taking metal carbonyl and heating in presence of desired ligand using aliphatic or aromatic ligand solvents. One has to be careful with aromatic solvents, because aromatic solvent itself can bind in eta 6 fashion to form, for example, if you take molybdenum hexacarbonyl and treat with benzene or reflux in benzene, you may form some sort of eta 6 arene coordinated tricarbonyl complex like C6H6 MoCO3. So, in order to prevent the formation of aromatic complexes, one should use solvents such as heptane or methycyclohexane, and heating to about 100 degree centigrade can give you thermally activated, where you can eliminate 1 or 2 carbon monoxide, and in its place you can bring desired phosphines or some other ligands. And then if you, another method is photochemical reaction, and photochemical reaction you do perform photochemical reaction using THF or something. Initially what happens, carbon monoxide comes out, and in its place loosely held THF coordination will be there, and later when you add a better sigma donor ligand such as phosphine, that can replace. And of course, when you, the advantage with photochemical reaction is you can monitor the reaction using IR, and IR can tell you by just looking into how many absorptions we are getting, stretching frequencies, you can observe whether it is forming eta 5, eta 4 or eta 3. That also depends on the type of ligands you are using, and sometime you also end up with getting a mixture of compounds, and you should be able to know how to separate them. If not, best is to go for CO4 complexes having 2 labile ligands, so that you can do it very easily in substitution reactions. So, those things also I will tell you. And another one is you can also use mild reagents to replace carbon monoxide at room temperature, and carbon monoxide comes out in the form of very inert gas, and in its place you can now the site that is vacated by carbon monoxide can be substituted by phosphines and other ligands. So, you can use 3 methods according to the convenience. To begin with, let me show you how to make some of these MoCO4 compounds having C2V symmetry. For example, if you take MoR in general MCO6, where M is chromium, molybdenum or tungsten, and treat this one with norbornadiene. It is also called NBD. Take in heptane, okay, take this with MoCO6 or MCO6 with slight excess of norbornadiene and heat it in heptane. What you can get is a compound of this type having 4 carbonyl groups. This is called bicycloheptadiene, this is also called norbornadiene, and here the advantage with this one is you can see this is a very strained chelating ligand, and because of this strain what happens, you can readily substitute this one with a bidentate ligand. For example, you take this one, treat with DPPM, perhaps you know what is DPPM already, we discussed it several times. It can readily form this type of compounds in almost quantitative yield. NBD comes out here. And sometime if there is a problem of separating NBD, what you can do the same reaction in reflexing in hexane. In that case, what happens at that temperature, when NBD comes out, it undergoes some sort of polymerization to form insoluble stuff, and that will stick to the walls inside, and as a result this compound is dissolved in hexane and that comes out very easily, and separation would be very easy. So, that is the advantage sometime performing this reaction with slightly higher temperature. So, NBD gets polymerized, sometimes it also forms cyclic polymers. One can use these compounds for further reactions. Of course, in case of chromium, molybdenum, tungsten, temperature little varies and also yields are little different. One can get good yield in case of molybdenum, and yields are much lower in case of chromium and tungsten. And in place of norbornadiene, one can also use cyclooctadiene also. This also one can use. This compound is slightly more stable compared to norbornadiene complexes, and again they have very characteristic smell. Once when they are replaced with appropriate ligands, you can also the smell the liberated one near the reaction, that also indicates that yes, your reaction is complete or substitution is going on or it is completed, you should be able to see. So, another couple of important compounds of molybdenum tungsten are having 4 carbon monoxide groups are these complex piperazine complexes, and this can also be made starting from MoCO6, MCO6 here. Only in case of molybdenum and tungsten one can make this compound. These piperidines will be binding here And this one you take these two and reflex in heptane within about 2 hours bright yellow precipitate is formed. One has to do hot filtration, you have to do hot filtration. Hot filtration will ensure that unreacted MoCO6 or WCO6 comes out, and after hot filtration whatever remains on the filter paper insoluble material, that is this compound. Of course, in heptane it is insoluble, whereas this compound is highly soluble in dichloromethane, and at room temperature if you add any other phosphines, 2 equivalents of monophosphines or a bisphosphine, you can readily knock off and make MCO4 complexes in almost quantitative yield. Why I am telling all these compounds are, you can further use these compounds to make molybdenum tungsten 2 complexes that are very widely used in metathesis, olefin metathesis and ring opening polymerization reactions and other things in organic chemistry. Okay, from that point of view these are very important reactions. Let me continue giving the preparation of several other interesting compounds as we go through the classification of ligands. That means I would stop at this juncture, and in my next lecture let me talk about the classification of ligands, and there are several ways to do classification. Let me do the classification by choosing donor atoms. So that way I can cover almost all ligands we come across under one donor atom. For example, hydrogen donor atom, nitrogen donor atom or oxygen donor atom or carbon donor atoms, all important ligands coming under those donor atoms would be discussed in detail. So until then, have an excellent time reading chemistry.